So hello, grade 11 students. In this session, we're going to continue with the revision about genetics. So we're going to move quickly about the notes that we talk about the dominant allele. The dominant allele is the one that is the strong allele that can be expressed in both homozygous and heterozygous. In the case of pure, both of them, they are dominant or one dominant and one recessive. The recessive allele is the weak allele. It cannot be expressed unless in the case of homozygous, and it should be two recessive alleles together in order to be expressed. Also, we think about the co-dominant is the alleles that are both expressed. This is the case of co-dominance. Also, we talk about the phenotype and the genotype. Phenotype is the sum of the traits. Genotype is the sum of alleles of an individual. Always the genotype will code for the phenotype. We talk about the true breeding line where the individuals and their descendants, they have the same phenotype as their parents. Homogametic, individual that gives only one type of gametes, example about this, the female ovum, while the heterogametic individual that gives more than one type of gamete, example about this, the male. Hollandric gene, the gene that is carried by Y chromosome, while bidominant and birecessive. So bidominant, meaning that individual having two dominant phenotypes, while birecessive having two recessive phenotypes. Dihomozygous, diheterozygous, the same concept. Individual homozygous for both traits is called dihomozygous. Diheterozygous, individual heterozygous for both traits. And also we said that we have the transmission of the genes. We said the steps of the factorial analysis, you have to know them. Yes, Mahdi, do you have any question before we continue?
أستاذ اليوم ما عنده إنترنت بس يجي بتفوت.
No problem, it's okay. So the phenotype of the individual, you have to start first with the phenotype of the individuals. Then you move to the second step, the genotype. So you have to know these steps of the factorial analysis. And then we will move to the gametes, table of cross, and finally the table of results. Table of cross, pay attention to this. If I ask you about the table of cross, I want you to verify the phenotypic percentages. You have to work in percentage. To verify the phenotypic proportions, so you have to work in a proportion, in fractions. So no one is allowed to start unless I ask you with. And for example, if I ask you to find the phenotypic proportions, so you have to work in a proportion. Even if you solve it in percentage, this is wrong. You have to solve it in proportion. If I ask you a percentage, you have to work it in percentage. But if I ask you to work it in percentage and you work it in proportion, even though it's correct 100%, it won't be corrected as correct. It's false. Because I ask you to proportion, you work it as percentage or vice versa. Here, you have to know that the steps, phenotype, genotype, the gametes, table of cross, and table of result. Table of cross and table of result should be drawn using a pencil and a ruler, not using your hands. And we know about test cross is the cross that's done to identify whether the dominant individual they are if homozygous or heterozygous. Co-dominance and intermediate co-dominance were both alleles they are expressed together. However, intermediate dominance is the case where we have a color or a trait that is intermediate between these two traits. In this case, both alleles they are dominant. In the case of co-dominance or the case of intermediate dominance, incomplete dominance, both alleles they are dominant, meaning that both of them they are capitalized, capital letter. Okay, so you have to pay attention to this. You may ask me, how can we identify whether it's in the case of co-dominance or incomplete dominance? It's very simple. If we have two alleles and both of them they are expressed, for example, we cross a white dog with a black dog. We got a dog that's spotted, black spotted with white spots. So here, both are expressed, the white and the black. So this is the case of co-dominance, where two alleles, they cooperate and they co-express. While intermediate dominance, I have, for example, a blue and let's say a white and a red. We get a pink, like this case in the snapdragon plants. So this is the case intermediate. So this is the case of intermediate dominance or called incomplete. And also both alleles they are dominants. And the pink doesn't have an allele P, for example. Here the planets always they are pure. So here we have RR as a genotype, and here we have WW. Both of them they are dominant. Sure, you have to give the symbols. So if you forgot to give the symbols, this means that your answer is not correct. This means that your answer is not correct. So skipping the symbols, even though I didn't ask for, skipping the symbols, sorry, will lead to all the parts down, they are false. And for example, you didn't mention that R allele, let R capital be the symbol of the red allele, which is in co-dominant with the white allele. Let W capital with be the symbol of the white allele, which is in co-dominant with the red allele. Here you can continue. Even you didn't mention this, even though you solved the whole exercise, it's all correct. All the parts down, they are going to be cancelled. So you have to pay attention to this. Pink flower, so here RR, we have gamete R, 100%. And here we have gamete W. So they meet together, so the pink will be R capital, W capital. F1 crossed with F1 will give the F2. So what do we call this? This is called the self-cross. Crossing the F1 with the F1 is called the self-cross. So after crossing F1 with F1, the self-cross, this leads to what? Leads to the appearance of three different traits. We have RR, red, we have pink, RW, and we have white, WW. So this is the case of the crossing F1 with F1. How? We will solve a similar exercise later on. So here the type of crosses. Here the type of crosses, we said we have three different type of crosses till now. First type of cross, it's called what? The mono-hybrid cross. The monohybrid cross. Who can tell me what is special about the monohybrid cross? Monohybrid cross. Raising your hands, please. Yes, Cynthia. Monohybrid cross.
Parents are pure and different only one trait.
Very good. The parents are pure, and they are meaning that they are homozygous, and they differ in only one trait: color of the hair, color of the skin, color of the eyes, and so on. Second type of the crosses is the self-cross. Self-cross, if I told you, justified, because we crossed two F1 individuals, or because two F1 individuals were crossed. Third cross, till now, is called the test cross. So we have till now three crosses. Test cross is done to identify whether the parents of dominant phenotype, they are homozygous or heterozygous. If we have in the descendants two different phenotypes, they are heterozygous. If we have in the descendants one phenotype, they are homozygous. Moving to the transmission of traits. Here we have transmission, hereditary transmissions. We have first the case of dominance. So one allele is dominant over the other allele, which is recessive. This case of dominance. Second case is the case of co-dominance. Co-dominance, where both alleles, they are expressed. And the third case is the case of incomplete dominance or intermediate dominance. You can use both words, intermediate or incomplete dominance. So here there are the three cases: intermediate dominance, co-dominance, and the case of dominance. Here they are the three different traits. Karyotype, we said what is the karyotype? It's the set of arranged set of chromosomes. They arrange according to the different criteria: decreasing order of size, position of the centromere, and the banding pattern. We talk about the gonosomes. They are the sex chromosomes. They are either XX or XY. XX in the case of female, XY in the case of male. Whenever we saw X, whenever we saw Y, so this means that this individual is a male. Whenever we see the sex chromosomes abnormality, so this person is sterile. Sterile meaning that it has abnormality in the fertility, so it's not fertile. It can give birth to individuals. Autosomes, they are all the chromosomes except the sex chromosome. So chromosome number, pair number 1 to pair number 22 in a human, they are considered as the autosomes. So this is the karyotype showing the different components. Every chromosome occurs in a pair. So this one is for a diploid cell. Chromosomal formula for the normal, 2n equal 46, comma XX for the female, 2n equal 46, comma XY for the male. Normal haploid, 1n equal 23 Y, 1n equal 23 X. If it's 1n equal 23 X, either for a male or female, while if it's 1n equal 23 Y, especially it's for a male. So chromosomal abnormality, as we said before, they are classified either numerical or structural. Numerical, either we have additional chromosome or a missing chromosome. So if we have additional, it will be 2n plus 1 equal 47. If we have a missing chromosome, 2n minus 1 equal 45. So this depends on what? This depends on the abnormality. If the abnormality is autosomal, this person is fertile, it can give birth. While if the abnormality in the chromosome, this means that the person is sterile, it can give birth. And if I told you, for example, what is the cause of this abnormality, we have extra chromosome in the case of Klinefelter syndrome, while in the case of Turner syndrome, we have a missing sex chromosome. If I say about the chromosomal structure, it affects the structure of the chromosome, and we talk about this in the case of Robertsonian translocation and chromosome 21 till chromosome 14. This is trisomy 21. And we talk about that as the maternal age increase, the Down syndrome frequency will increase. So they are directly proportional. And we talk about the chromosomal formula of the Turner syndrome. It's always 2n minus 1 equal 45, comma x0. And for the Klinefelter syndrome, 2n plus 1 equal 47, comma xxy. Also, we talk about the Karyotype syndrome. We have a missing chromosome of the pair number 5. So this leads to the Karyotype syndrome. And now I'm going to move to this karyotypes. These two karyotypes, they show one chromosome of each pair. So we'll have one chromosome. So we don't have two chromosomes. So the first one, this is the first karyotype, and this is the second karyotype. If I ask you, Yamahdi, what does this karyotype represent? One, karyotype number 1, diploid or haploid? Yes,
شو يا أستاذ؟
karyotype number 1. Here, okay, this is the first karyotype. It belongs to a male or a female?
شو يا أستاذ؟ ما سمعت.
Karyotype 1, Mahdi. You hear me now?
إيش شو مالك؟
Karyotype number 1. بتسلم عليك ما مالها شيء. So karyotype number 1. First of all, it's diploid or haploid?
هايبلويد.
Why? Justify your answer.
لأنه ما في من كل وحدة
Because we have only one copy of each chromosome, so you can answer in English, yeah. So because we have one copy of each chromosome. Thank you, Yusuf. What do you think? This belongs to a male or female?
Number 1 belongs to a male.
Male. Why?
Because there's a Y.
There is a Y. Where is the Y?
Under 18.
There's not. This Y is missing.
Oh.
There's nothing. We have
sorry.
only the X.
So it's an X and O. So female.
So here we don't have Y. So here you can neglect this. We have only the X. It's for?
It's a female.
Female. Only for a female. First of all, whenever we have a haploid, Yusuf, this would mean that either it's a sperm or an ovum, right? It's a female gamete or a male gamete. So you said it's X, it's for a female, right? And meaning that it's for an ovum. Okay, thank you, Yusuf. Thank you. What do you think, Hani? Yusuf said it's only for a female. True?
Yes, Ustaz.
Yes, Yusuf said it's for a female, meaning that it's for an ovum, since it have an X chromosome. What do you think? Yes, honey?
It can be for both.
It can be for both. Why? Because the sperm can carry X or Y.
Yes.
While the female can carry only X.
X.
So it can be for a sperm or it can be for an ovum. So it can be both, Yusuf. Thank you, honey. So it can be both.
You're welcome.
Either for a sperm or for an ovum. What do you think, Joanne? The karyotype number 2 is for a male or female? Sperm cell or gamete or a ovum?
No, it's a male.
It's a male for a sperm or for an ovum, yani?
Sperm.
Sperm, why?
Because there is a Y and
Why?
the X chromosome is missing.
So we don't have X chromosome. This for a haploid. So always whenever we have one copy of each chromosome, thank you, Joel. So one copy of each chromosome. So this belongs to a haploid cell. So either it's a sperm or an ovum. In this case, the first one contains X. So X, it can be both. Either. So here, you can give me the chromosomal formula by raising your hands. The chromosomal formula for the first karyotype. For the first karyotype, I need the chromosomal formula. Who can give me the chromosomal formula? Yes. I'm going to choose Ran. What do you think? Ran, what do you think? Okay, I think Rain can't hear me. Lynn, yes. Can you give the chromosomal formula for the first karyotype?
1n equal 23.
Very good. 1n
XX
equal
or
23.
XY.
1n equal 23, comma. What are the sex
XX
chromosomes?
or XY.
XX or XY? You
Oh
don't have
no,
only X.
just X.
So 1n equal 23, comma. It's X
X.
here. Why the second is going to be 1n equal 23, comma.
XY.
XY, we don't have only one. So 1n equal to 3 equal y, comma y.
Okay.
Okay, so always whenever it's a haploid, we're gonna have only one sex chromosome, either X or Y, and it's equal to 1n equal 23. Thank you, Aline. So let's continue now with the first exercise in the worksheet, chromosomal abnormality. Sometimes you're going to see anomaly. Anomaly, abnormality, they have the same meaning. Here, Mona and Samir, they have 3 children, 2 daughters and a son. 2 of them, they present several physical deformation. They have several physical deformation or several physical abnormalities. So the family visited a geneticist who subjected the chromosomal abnormalities. As such, the karyotypes of the 3 children were obtained and shown in the figures below. Here we have figure 1, figure 2, and figure 3. So here I need new voices بدي اسمع اصوات جديده. Nada, good morning.
Good morning.
So figure 1, have a look on figure 1 and give me the chromosomal formula. First of all, before you give me the chromosomal formula, it's a haploid or a diploid, justify your answer. First of all, figure 1.
It's a diploid because we have 2 copies of each chromosome.
Very good. Give me the chromosomal formula.
2n
Yes.
equal 2n minus 1
Yes.
equal 45
Yes.
x.
Comma x or x0. You have to put it like this. Okay. Why did you say this?
Because we have a missing
Autosome
sex
or
chromosome.
sex chromosome. Very good. So we have here a missing sex chromosome. Okay. So what do you think, Nada? This person is fertile or sterile?
It's sterile
Why?
because it has an abnormality in the sex chromosome.
Okay. What do we call this abnormality?
Klinefelter's
You have a missing chromosome. What do we call it? Turner
syndrome.
syndrome. What is the type of this abnormality? Autosomal or gonosomal?
Gonosomal.
Gonosomal. Thank you, Nada. Thank you. Let's move now to the second figure, figure 2. Figure 2. Hassan Zaidan. Good morning.
Good morning.
So what do you think, Hassan? This is figure 2. Is diploid or haploid?
Haploid.
Haploid. Why?
عشان we have XY.
We have XY, so it's a haploid. First of all, Hassan, what the meaning of haploid and what the meaning of diploid?
الدبلويد بالدبلويد
Yes.
يكون في copies of each chromosome.
Okay, عندك بهيدي الفكرة عندك 1 copy ولا 2 copies of each chromosome؟
2 copies.
يعني it's a haploid or a diploid؟
Diploid.
شوف كيف؟ هذه diploid. So first of all, it's a diploid. Can you give me the chromosomal formula? So always diploid يعني 2m.
Equal 46.
قبل ما تطلع 46 طلعت عليها الكاريوتايب فيها شيء abnormality؟
لا.
ما فيها abnormality ever؟
No.
Okay, so 2n equal
46.
46. خلصت chromosomal formula eh?
XY.
Comma XY. So this is a male or female?
It's a male.
Justify.
And Y.
Because
female.
we have a Y as a sex chromosome. Very good. So here let's continue with the chromosomal formula for figure 3. Mirna, good morning. Thank you, Hassan. Mirna, good morning. Ali Bustani, good morning, Ali.
Good morning, Esther.
So, Ali, figure 3. They
Yeah.
ask you, diploid or haploid, justify your answer
Diploid لأنه في 2 copies.
of each chromosome. First of all, give the chromosomal formula. Look at the karyotype 1. We have additional chromosome, we have missing chromosome or normal.
No, it's normal. ما عندنا missing chromosome.
Okay, so it's normal. So chromosomal formula,
2n equal 46.
yes, 2n equal 46. And what is it?
X ما عندنا Y.
So XX.
Yeah.
Okay, thank you, Ali. Thank you. What do you think, Muhammad Hassan? The Alan Ali صح؟
أستاذ 2n plus 1 equal 47.
ليش؟ ركز معنا علي. 2n
أستاذ
plus 1 عم بيقول لي محمد، ليه 2n plus 1 equal 47؟
لأنه نمبر 8 في 3 كروموزوم.
Exactly. So 2n plus 1 equal 47, comma, XX. Thank you, Muhammad. Ali, did you pay attention here? We have 3 chromosomes on pair number 8.
ما شفتها وحياة أمي يا أستاذ.
Okay, so here we have additional chromosome on pair number 8. So here we have abnormality. So if I ask, I want a new voices here. Tala, good morning.
Good morning.
So here we have additional chromosome on pair 8. So what do we call this abnormality? What
Yeah.
is the name?
Trisomy 8.
Trisomy 8, very good. So what is the type? Autosomal or gonosomal?
Autosomal.
Since it affects
The autosomes.
sterile or fertile?
Fertile.
Why?
Because it doesn't affect the sex chromosomes.
Very good. That's it. Thank you, Tala. So let's continue. Were these karyotype obtained from diploid or haploid cell? Justify your answer. Already we solved this, that they belong to diploid cells. Justify your answer because we have 2 copies of each chromosome. Draw the corresponding chromosomal formula to each karyotype. The first one, already we wrote it. It's 2n minus 1 equal 45, comma, XO or X0. Since we have a missing chromosome in the sex chromosome, so we have 1 missing chromosome in the sex chromosomes here. And also the second one is normal, so it's 2n equal 46, comma, XY. Here, sometimes I don't give you X and Y here. So you have to know one is big and the other one is small. So one is X and the second one is Y. Always the X is going to be larger. Here, maybe I'm not going to give you these. So 2 of the same size. So أكيد حيكونوا اثنيناتهم X ما حيكونوا اثنيناتهم Y. One of these karyotypes correspond to the normal type. Which one? Is the figure 2. Since 2n equal 46, comma, XY. Referring to the above karyotype, name the abnormality from which the other children suffer. In figure 1, the children suffer from Turner syndrome, while in figure 3, the children suffers from trisomy 8. Indicate the reason of the abnormality in each. What is the reason? In the first figure, we have a missing sex chromosome. So we have only 1 sex chromosome, which is the X. And this is the reason. While in the figure 3, what do we have? We have additional chromosome on the pair number 8. This can be explained. We have 3 pairs instead, 3 copies instead of having 2 copies. Indicate the sex of the individual to which of these karyotypes belongs to. First figure, it has only X chromosome, so it belongs to a female. Then figure 2, it has XY as sex chromosome, so it belongs to a male. And figure 3, it belongs to a female since it has 2 X chromosomes. Part F, which of these karyotypes should correspond to a sterile individual? Justify it. Which of one of these? This one is normal. So this one, it has trisomy 8, the autosomal abnormality. So this one is fertile, not sterile. While the third one, our figure 1, it has abnormality at the level of the gonosome. So here we have gonosomal abnormality. So gonosomal abnormality, this means that this is the karyotype that belongs to the sterile individual. So this person is sterile. So whenever the abnormality affects the gonosomes, this means that this is a problem in fertility and the person here is sterile. Here we finished the exercise number 1 in the worksheet. So we still have 2 exercises, exercise 2 and exercise 3. So let's move to the solution. So they belong to diploid since they contain 2 copies of each chromosome. Figure 1, 2n minus 1 equal 45, comma XO. Figure 2, 2n equal 46, comma xy, and figure 3 2n plus 1 equal 47, comma xx. Which one correspond to the normal? Figure 2. And D, figure 1, Turner syndrome. In figure 3, we have trisomy, the name of the abnormalities. In figure 1, what is the reason we have missing chromosome in the gonosome? Figure 3, we have additional chromosome in the pair number 8. Figure 1, it's a female, since it shows only one X as sex chromosome, and it's the Turner syndrome. Figure 2, it's a male, since it shows X and Y as sex chromosomes. Figure 3, it's a female, since it has XX as sex chromosomes. Part F, they said which one is sterile? Figure 1, since the abnormality occurs in the gonosomes, and you can say it's a gonosomal abnormality, or it affects the sex chromosomes. So this is everything for our session today. Next session, we're going to continue with exercises 2 and 3, solving the exercises, and we are going to review the notes together in the next session to prepare ourselves for our quiz.